Alright, so for today's video lesson, we're going to do extreme values, and these are problems in economics. Okay, so these is part of our section 1, max-min problems, and here we are applying them to economics. And this application is for like executives or people who own the company. They want to, of course, maximize profits or revenue. But at the same time, they also want to minimize costs, okay? So this is a really good application for derivatives here, okay? So first thing we're going to introduce is the cost function, okay? So we're going to talk about 3 different functions today. We're going to talk about the cost function. We're going to talk about the revenue function. And what's the last one? The profit, what do we want to call that? The profit function, I guess, okay? So we have cost function, revenue function, and the profit function. The profit function is really just a combination of the cost and the revenue function, okay? So we're going to talk about 3 different types of functions today. So we will have 3 examples, okay? So first thing we are going to talk about is the cost function. So this is what it costs a company to produce X units of a product, okay? So cost is equal to fixed cost plus the variable costs. So fixed costs could be like how much it costs the company to actually create that product. Okay, the variable cost is going to be like what the actual price at which we sell those products are at. Okay, so fixed cost is going to be just represented by F. And variable cost is going to be represented by X multiplied by the price of X. Okay, so X here will represent the number of units produced. And P is going to represent the price per unit. Okay, so once we have taken into consideration our fixed costs and our variable costs, if we take the derivative of the cost function, so C prime of X, this is called the marginal cost. And this is used to calculate minimum costs, okay? Again, business people want to maximize revenue and they also want to minimize the costs. All right, so let's get into our first example here. Now this question is probably going to take the whole page, so you might just want to do your notes on that blank sheet of paper that's included in there. Okay, so manufacturing company determines the variable cost, so the variable cost, right, of producing a certain number of microwaves is described by the function X multiplied by 0.5x plus 120. Okay, so that is the variable cost, right? So remember the cost function, so C of X is equal to the fixed cost plus the variable cost, which is X times P of X. Remember, this is variable costs, and we actually are given that in this equation, okay? So let's set up this equation here. So C is going to be my average cost. Average cost per unit. Okay, so note we have our formula to calculate the average cost per unit. So we're just going to divide the cost function by how many units we produce, okay? So C is going to be our average cost. Remember, this is a minimum function. And C of X is going to be the cost of producing X amount of microwaves. Okay, so C of X is going to be the cost of producing X microwaves, okay? If the fixed costs are calculated to be $20,000, so F is 20,000, how many microwaves should be produced in order for the average cost to be minimized, okay? So again, fixed costs, that's going to be like the money required to extract the materials required to build a microwave, okay? All right, so we know our variable cost and we know our fixed cost, so let's combine these to have our cost function here. Okay, so C of X is equal to the fixed cost, which is 20,000, plus our variable cost, which is X multiplied by 0.5X plus 120. Okay, so let's distribute that X into our brackets. So we have 20,000 is equal to plus 0.5x squared plus 120x. Okay, so that is going to be my cost function. Okay, but remember, we want to find the average cost. We want to minimize the average cost. So is what we have to do here, we have to divide our C of X divided by X to find the cost per unit. Okay? So we want to do C of X is equal to 20,000 plus 0.5 x squared plus 120x. If you wanted to rearrange that so it's from highest exponent to lowest exponent, you're obviously welcome to do that. And this is all divided by x. Okay, so let's clean this up. So C of X is equal to 20,000 over X plus 0.5 x to the 1 plus 120. Okay, we can rewrite that 20,000 over X as 20,000 x to the minus 1. Okay, so this is our average cost function here. Okay, so now let's go ahead and find C prime of X. So 20,000 multiplied by -1 is negative 20,000 x to the negative 2 plus 0.5. Okay, and while we're at it, let's take our second derivative to ensure that this is indeed a minimum function. So C double prime will give me positive 40,000 x to the negative 3 Okay, so that is my second derivative. We can rewrite that as 40,000 divided by x cubed. Okay, and we're just going to hang on to that for a little bit. Okay, so now that we've taken the first derivative, let's rewrite this so it looks a little neater. So we have negative 20,000 over x squared plus 0.5 is equal to 0. Okay, so we'll solve for x. So we will add 20,000 x squared to both sides. These will cancel, and then we're left with 20,000 over x squared is equal to 0.5. We will multiply both sides by x squared. Those will cancel. And to get x by itself, I'm going to also divide by 0.5. Those cancel. Now I'm left with x squared is equal to 20,000 divided by 0.5, which is 40,000. And then lastly, we'll take the square root of both sides, get an x value equal to 200. Okay, so we know our x value. Remember, x is the amount of units sold. Okay, so 200 microwaves is our minimum value, hopefully. Let's just double check over here. We'll substitute this in at x equals 200. And this will be positive. Therefore, it is a minimum. Okay, we're taking the second derivative test just to check our answers, right? Okay, so, and lastly, we got to make sure that we answer the question here. So therefore, the average cost is minimized when 200 units are produced. Okay, so that is the cost function. Okay, so let's do another cost function problem here, okay? Actually, we are going to skip this one. Okay, so that's the cost function. Now I would like to talk about the revenue function. So the revenue function determines the total revenue, okay? So revenue, or R of x, is going to equal x multiplied by P of x. Okay, x here is going to be number of units sold, and P of x is going to be the price per unit. Okay, so the derivative of the revenue function is called marginal revenue. And is used to calculate revenues and profits. Okay, so we just looked at the revenue function up there, and now we're going to talk about profit. So profit is equal to the revenue. So the money generated from the sales, subtract the cost at which it takes them to produce those goods, okay? So revenue, we just talked about the revenue function is R of x. And the cost function, which we talked about in the last example, is C of x. Okay, so the profit function is equal to revenue minus cost, and revenue function is number of units sold multiplied by the price, and the cost is what we just looked at last question. The cost is fixed cost plus the variable costs. Okay, so let's get into a revenue problem here. Okay, this one is just revenue, and then the last one we're going to look at is exploring the profit function. Okay, so example 3. So a tour company offers ski excursions at $160 per person for groups up to 50. For groups larger than 50, the company will reduce the cost of the ticket by $2 per person when the group is in excess of 50. So the question is, what group size will produce the greatest revenue? Okay, so again, I think that the hardest part with these word problems is setting them up. Okay, so from this question, and just from analysts, we know that the major factor here is the group size over 50. Okay, so as we set this up, we're looking to find what group size will produce the greatest revenue. So let's let x equal the number of excess people above 50. So x is the number of people in excess of 50. We will let 50 plus x equal the total number of people on the ski trip. Okay, the ticket price is going to be 160, right? That's our base price. Subtract 2 times x. Okay, and this is going to be our reduced ticket price. Right? 160 minus 2x, so $160 is the base price, and that will be subtracted by $2 for each person in excess over 50. Okay, and our last variable that we're going to set up is going to be our R, and that is going to be revenue. Okay, so from the revenue function, we know that R of x is equal to x multiplied, so x is the number of units sold multiplied by the price of x. Okay, so x is going to be the number of people in excess over 50, and the total number of people on the ski trip is going to be 50 plus x. Now remember that x in our revenue function is number of units or tickets sold. So how many tickets will we sell? Well, it's going to be 50 plus x, right? Because we're in excess of 50, and the price is going to be 160 minus 2x. Okay, so we can expand these brackets so it's easier for us to solve. So 50 times 160 is 8,000. minus 100x plus 160x will give me positive 60x. And negative 2x multiplied by x will give me negative 2x squared. Okay, once you have it at this point here, let's take the derivative of this. Okay, so r prime of x is equal to 60 minus 4x. And while we're at it, let's take r double prime of x, which is going to equal negative 4, which is always negative. Therefore, it is a max value. I'm just kind of hang that to the side. Remember, the second derivative test is just allowing us to confirm that, right? Okay, so we're looking for a max value, so let's set this equal to 0. And solve for x, so add 4x to both sides. Divide by 4. X is equal to 15. Okay, so what is x? X equals to 15. So what? Well, we said x is going to be the number of people in excess of 50, and the total number of people on the ski trip will be 50 plus x. Okay, so number of people is going to be 50 plus x, which is 50 plus 15 equals 65 people will be on the trip. What will be the ticket price? Well, the ticket price was 160 minus 2x. So 160 minus 2 times 15 is equal to 130. So that is going to be our ticket price. And our revenue is number of tickets sold multiplied by the price. So x times p of x, we know we're going to sell 65 tickets multiplied by $130, giving us a revenue of $8,450. Okay, so at the end, once you've found your derivative and your maximum or your minimum, make sure that you are indeed answering the question, right? Make sure we are answering the group size. Make sure we are finding the ticket price and how we are finding the revenue. Okay? So, last example for this lesson. So we want to maximize our profit here. Okay, so remember, profit is equal to the revenue minus the cost. Okay, so a toy retailer finds that 100 teddy bears can be sold if each is priced at $12. However, 20 more teddy bears can be sold for every $1 decrease in price. The cost of each bear is $6. And in addition, the retailer must pay a fixed cost of $150. How should the bears be priced in order to realize the most profit? Okay? So we are looking to realize the most profit equals max Okay, we're looking to maximize the profit here. So I'm going to let P equal profit max. And I'm going to let, excuse me, I'm going to let X equal the number of price increases or decreases. Okay, we know that the profit is equal to the revenue minus cost, so let's write this. So profit, P of X, is equal to the revenue minus the cost. Okay, so we can, let's find R of X, let's find our revenue first, okay? We're going to kind of break this up and then we'll combine them towards the end. Okay, so revenue, so revenue function is equal to the number of units sold multiplied by the price. Okay, the number of units sold, okay, number of units sold, that is, it can sell 100 teddy bears and it can also sell 20 more if we decrease the price. Okay? So the number of units sold is going to be 100 minus 20, or sorry, plus 20. Plus 20x, so 100 teddy bears plus 20, depending on how many price adjustments we make. And the price is going to be, so it's priced at $12, and for every $1 decrease in price, they can sell more, okay? So the price is going to be 12 minus 1x, right? 12 minus x. How many price adjustments we're going to make. Okay, so once we're at that point, let's expand this. So R of X is equal to 1200 minus 100x plus 240x minus 20x squared. 240. Okay? We have like terms, x. So let's clean those up. So we have, and I'm just going to rearrange this. We have negative 20x squared plus 140x plus 1200. Okay, so let's leave that for now. Okay, now that we found our revenue function, we're just going to leave that alone until we have figured out our cost function, and then we are going to put those two together. Okay, so let's move over to the cost function now. So cost function is equal to the fixed price plus the base cost multiplied by the number of units sold. Okay, so here is my base cost. F is going to be fixed cost, and then my P is going to be the price, and my X in there is number of units sold. Okay, number of units sold. We represented that right here, right? The revenue function is number of units sold, so that's going to be right there, okay? We also know the fixed cost is $150, so we know our F. And the cost of each bear, the base cost, is $6 there. Okay? So let's go ahead and put those into our cost function. So C of x is equal to 150. Okay, I'm just going to move that so it's out of my way. Don't forget that x is the number of units sold, right? Plus 6, which is my base cost, multiplied by the number of units sold, which is going to be 100 plus 2x. Okay, remember the cost function is fixed cost plus variable costs, and variable cost is the base price multiplied by the number of units sold. Okay, so we can simplify this. We can distribute that 6 into those brackets. So we get 150 plus 600 plus 12x. Okay, now we know our cost function. I should simplify that. Okay, so we have 150 and 600, so that will give me 12x plus 750 is my simplified cost function. Okay, so now that I know my cost and revenue functions, we can combine them into the profit function. Okay, so P of x is equal to R of x minus C of x. So we are going to have negative 20x squared plus 140x plus 1200 minus my cost function. So minus I just realized I made a mistake. 6 times 20x. Right, it is 20x. Because they can sell 20 more bears depending on how many price changes they make. Okay, so sorry about that. Right here I made an error. It should be 20x. Okay, so instead of it being 12x plus 750, it should be 120x. My apologies. Just off by a factor of 10. Okay? So anyway, so we're going to subtract that. So it's subtract 120x plus 750. Let's go ahead and distribute that negative sign in there. So you'll have negative 120x and negative 750. So negative 20x squared can stay. 140x minus 120x leaves me with 20x. And 1200 minus 750 will leave me with positive 450. Okay, at this point here, let's go ahead and take the derivative. So P prime of x is equal to negative 40x plus 20. Okay, we can take the second derivative here as well while we're at it to test our concavity. So the double derivative of P of x is going to be negative 40, which is always negative. Therefore, it is a max, which is good because that's what we're looking for, right? Okay, so let's set this equal to 0 now. So 0 is equal to negative 40x plus 20. We'll add 20x to both sides. Divide by 20. and we're adding 40x to each side, not 20x. Okay, those still cancel. Divide by 40 to get x by itself. And then we're left with x is equal to 1 over 2. Okay? So x equals 1 over 2. So what? Remember, we let x equal the number of price increases or decreases. So they're saying that they want half a decrease. Okay? So we found our x, but we still need to answer the question, right? How should the bears be priced in order to realize the most profit? So let's jump back to the top and remember the price for each bear was represented by the expression 12 minus 1x. So price was 12 minus x at x equals 0.5. 12 minus 0.5 equals 11.50. Okay, so the bears should be priced at $11.50 to maximize the profits here. All right. So those are 3 different examples. The first one we looked at the cost function. The second example we looked at was the revenue function, and the last one was the profit function. Okay, so your assignment for tomorrow's class, or for the remainder of today's class, is to do 1 question of each. So you can select between questions 2 and 4, whatever's more interesting from you, or for you, okay? So make sure we do 1 of each and submit to the Google Classroom. When you're done, or you can text it or email it to me, that is fine. Okay, so for Tuesday's class, you guys will have some time to work on these, okay? So Tuesday will be a work period, and for the remainder of today, for the last 8 minutes, you can go hang out with your siblings or with your pets. Okay? So thank you for your attention today, and if you have any questions or need help with anything, please don't hesitate to reach out. I'm more than happy to assist you. Okay? Have a great day, and we'll see you soon.